This is acid and base video number 3. By the end of this video, you should be able to calculate concentration and volume of an unknown acid or base using stoichiometry. Before you get started, you should have your acid and base video number 3 worksheet, a calculator, a periodic table, and a pencil. Something else that might be handy will be your mole map, which is still saved on Edline in the gases unit, which is the last time you used it. Example number 1. A student reacts 15.25 milliliters of 0.17 molar HCl with 23.74 milliliters of sodium hydroxide. If the acid and base are fully neutralized, what was the original concentration of NaOH? Well, first off, neutralized just means that all the NaOH and HCl has been fully reacted and you don't have any leftovers. This is good because it means you do not have a limited reactant problem. Next, because you have a reaction, you want to do the balanced chemical equation. Now, HCl and NaOH is a double displacement reaction. The Na goes with the Cl, and because the Na is a +1 from the periodic table and the Cl is a -1, that's balanced as it is, then the H goes to the OH to make water. If you count the number of elements of each type of atom, or the number of atoms of each type of element, you will find that they are equivalent on both sides, and this is a balanced chemical equation. Next, whenever you see molarity or molality, you should be expanding the unit. Show what this really means. So 0.17 molar means you have 0.17 moles per every 1 liter of HCl. So this becomes a conversion factor. Now the milliliters, we want to rewrite those as liters. So take your milliliters, divide that by 1,000 to get your liters. We're now ready to get started. We want to find the concentration of NaOH. We're going to do this in molarity. Molarity means that we want the moles of NaOH divided by the liters. We already have the liters here, so I'm going to go ahead and plug that in. What we don't have is the number of moles of NaOH. I'm going to find that by stoichiometry. Now I know more about the HCl, so I'm going to start there. This is my given, that's my conversion factor. So 0.01525 liters HCl. We're going to bring down the unit, so bring down the liters of HCl and go from liters to moles. This is our molarity, 0.17 moles, so 0.17 moles per 1 liter. Make that look like a decimal. Now I'm going to bring my moles of HCl down so they can cancel, and the moles of NaOH on the top, which I get from my balanced chemical equation. See how I have moles to moles? So 1 to 1, mole to mole ratio. Now to double check, my liters of HCl can cancel with each other, my moles can cancel with each other, and I will end up with moles of NaOH as my answer. This is 0.0025925 moles NaOH. Excuse me, 1 second here. So NaOH. Now this is going to go up here. So then top divided by the bottom, and I get an answer of 0.11 molar, that's rounded, NaOH as my final answer. Okay, next problem. A student reacts 7.63 milliliters of 0.86 molar barium hydroxide with 1.10 molar HBr. If the acid and base are fully neutralized, how many milliliters of HBr will the student use? First, we need a balanced chemical equation. And as expected, when we have Arrhenius acid and Arrhenius base, it's going to be a double displacement. So the barium goes with the bromine. Barium on your periodic table is a +2. Bromine is a -1. So I'm going to need to have 2 bromines. So this is a 0 or neutral molecule, compound. H goes with OH to give H2O. This is not balanced. I have 2 bromines, so I put a 2 out in front. I have 2 oxygens, so I put a 2 out in front. This gives me 4 hydrogens. 2 plus 2 is 4, and 1 barium on each. So I'm now balanced. Whenever you have molarities, you want to rewrite these. So this means I have 0.86 moles per 1 liter of barium hydroxide. And this means I have 1.10 moles per every 1 liter of HBr. Then the milliliters, divide that by 1,000 to get the number of liters. Okay, let's get started. We want to find milliliters of HBr, but we know more about the barium hydroxide, so I start there. Don't start with the conversion factor, start with the given. So we have 0.00763 liters barium hydroxide. We're going to bring the liters of barium hydroxide down. And we can go from liters to moles using the molarity. According to this, I have 0.86 moles for every 1 liter. I'm going to bring the moles of BaOH2 down. And I want to go from moles to moles of HBr in this case. Now your mole to mole step goes to the balanced chemical equation is a 2 to 1. So 2 to 1. Now I'm looking for milliliters of HBr, so I'm not done. Moles of HBr come down. And I'm going to go from moles to liters. Using my molarity, it's 1.10 moles. So 1.10 moles per 1 liter. And I want to cancel out what I can unit-wise. Liters of barium hydroxide cancels. Moles of barium hydroxide cancel. Moles of HBr cancels. And after multiplying across the top and dividing my bottoms, I get 0.0119 liters. Times that by 1,000, and you get 11.9 milliliters for your answer.